Hello and welcome to Codebase Alpha. This is our Wednesday early show, and we're all ready to go. I've got a cat here actually that's wandering around at my feet, meowing at me, so hopefully he won't disturb us too much. Okay, so what I'd like to do today is look at some of the issues I found with the code I wrote in the last stream. Only minor things. Afternoon, Coded Beard. Welcome to the stream. Then I'd like to do some refactoring. There's a couple of things that need refactoring, including the code we brought in from that Microsoft document about the Azure Key Vault, which turns out isn't very good code, so we need to refactor that. I also want to move our middleware into our library and maybe even to write some tests. Ancient Coder, welcome. Okay, so first we'll start off by giving a quick run through of the issues that I found with the code I wrote last time. So the first thing that I noticed this while watching back the video, is that I actually misspelt this this text here. So skill ID had a lowercase, and then I noticed that this system diagnostics trace write line wasn't showing up in the Azure logs, and so what I've decided to do, apart from fixing that spelling mistake there, I went across into my program file and I added logging. This is the Microsoft extension logging into there, and I particularly added the Azure Web App Diagnostics sync there to the logging. So what we need to do first is to actually bring that into our Alexa controller. So we can inject that using our IOC container. So we'll just do that. So ilogger logger. We just need to bring in the using statement for that. Extensions logging, and create a little private variable for that. Private ilogger logger, and assign it down here. Okay, and then what we can do is, instead of doing this, we can replace that with logger.logerror. And we don't need this flush anymore. Okay, Gareth, welcome. Yes, we've got a webcam. We are webcammed up. You can see the ironing board behind me here. This is where all the washing is. Normally, the washing is now scattered around the living room, but all that's left is that ironing board. So eventually, in the fullness of time, I'll buy an Elgato green screen and try and get green screened into the corner here. But for the moment, this is what we're doing. Okay, so we've got that change made. Now, the other thing that I found was that I needed to inject the same logger into. We know that's right. We need to make that sure it's a logger for the So over here we've got the logger coming in for the request validation as middleware as well. But we're going to do the same thing. We're going to make it the generic type there. So this is Alexa controller. There we go. Okay, so that should log now correctly. Same ironing board you have, Coded Bird. Yes, it's one from Tesco. So yes, Gareth, I do agree that the Elgato green screen is about 150 quid, which seems an awful lot of money. A green sheet would be great, wouldn't it? But I've got nowhere to hang a sheet in this room, so unfortunately can't do that. So we need to change this as well to be Alexa controller. And that squiggly should go away. There we go. So that's now happy. Over here in the validation control, I've done the same thing. So I've brought in the logger here and replaced our system diagnostic trace write line with this log error. Paid 20 quid for your green screen, Cody Bird, and maybe you'd like to drop into chat where you got that from. Yeah, the light setup is the other thing that would worry me, in that I've got this main light. I've got my my Razer Kaio has got its own light ring on it. I've got another lamp which is kind of pointing off in that direction. No, that direction. Not a direct light, just some reflected light. I guess I might be able to use that lamp to light a green screen. There's an Amazon one is a coded beer. Yeah, pop a link into. Well, you might not be able to pop a link in actually. So if you could, I'll sort that out in a bit. I don't want to break kind of concentration because I haven't got. This is not won't be a hugely long stream, so we want to make sure we get as much actual coding done today as possible. Because this is kind of, I think Gareth pointed out that yeah, into Discord, that'd be great. Good idea. Gareth pointed out you don't actually get an awful lot completed on the stream, so we want to get as much as possible. I'm not sure we'll get as far as I kind of hoped, but there we go. Okay, the other thing that I've done in here is just to replace the try get value with actually getting the value directly. When I was doing some off-stream testing, I didn't find that very reliable, so I'm actually just finding getting the headers, getting the header with the key signature cert chain URL, which we do know exists because we check up there. If there's any data in there, then we get the first entry and pass that into our cert chain URL. Otherwise, we pass empty. Then we check whether we've got is null or white space for that. So we're going to kind of call a halt to that bit there and work on it a bit later, hopefully within the same stream, but you never know. Okay, so that was on sale, that was it, so that green screen coded beard. Well, never mind, it's probably cheaper than 150 quid, I should imagine. Again, yes, yeah, I do find that it's quite variable, isn't it? But I don't tend to get an awful lot written. I think I could probably write a lot of this in a couple of days, and it's taking, you know, this is episode 5, part 5, episode 8, so yeah, I'm not getting a lot done. But never mind, it's all about kind of learning together and just exploring what we can do with C# and with our Alexa skill. So the next thing I'd like to do is we're going to come back to this and actually move this middleware out of our web project and move it into the library. But what we'll do first is go back to our startup class because there's some work to do here. So this code here was what we pulled out of a Microsoft documentation on the internet, and it's basically not very good. So what I'm going to do is actually pull this out into its own method, and then we're going to actually work on it. So let's refactor this. See, this is where I forget that I'm not using. I haven't got resharper, so we'll just grab all of this. Copy it out. We'll create a new private method down here. Private string get skill app ID. And we'll just paste that into there for now, and we'll return string.empty at the end of this. String.empty, there we go. Okay, so actually if you look closely at this code, it is pretty ridiculous. So for example, we're getting the skill ID here. Then we've got this completely useless do while loop, which isn't doing what it says it does. It says an example of throttling or of handling throttling errors, and it's not actually doing that. So we're going to correct that. So we want to first comment out these two lines, and we'll get rid of this comment. So I think it's supposed to be just example code, but it's really messed up. And I don't really understand why they've provided it at all. Okay, so we'll get rid of this this message as well. So when we come into this do loop, and we do want a do loop, we want to go through at least once. So this is one of those occasions where a do while is quite appropriate. Make sure we go through the loop at least once. What we need to do here, right, we need to we'll via that get the wait time. Now this wait time is coming back currently from this get wait time method, and I don't like the fact it's got a lowercase g there, so we'll change that. That method's down here, and I'm not really sure why it's returning a long either, so we want an int really. It's returning wait time. We'll just via that. Okay, so we got that. Let's go back up here. So this do loop, we get in our retry. So if we've got any retries, then we're going to have this kind of exponential kind of delay. So it's going to be 1 second, 2 seconds, 4 seconds, 8 seconds, that kind of idea, up to a maximum of this many. So that's quite a large number anyway. So that's the maximum it's going to retry. So our secret here, this is going to be this configuration value. Oops, don't want to do that. We want to return that value actually at this point. So okay, retry is false. Okay, so let's think this through logically. We're going to do here, and we're going to, oops, I'm sure I changed that. Oh, I've pasted back in. No, that's why. Well, that was a bit weird. Let's get rid of all that. Sorry about that. It's confusing myself. We're back in our private method, aren't we, down here? So we got the secret here. With our do loop, and we're going to want to sleep. So we'll just put a threading dot thread, and we'll sleep for wait time. And we need to make sure we don't sleep the first time through this loop. So we'll sort that out in a second. And then our try catch doesn't belong here. Our try catch actually should be around the attempt to actually access the key vault. So we'll pop that around there, and we'll just do a format document so it's nice and neat. We can uncomment this, which we commented out last time. I don't like having things on one line like that, so I'm going to put curly braces around there. And also we need to increment our retries. Okay, so now if we throw this error, if we throw this status code of 429, then we're going to retry and we're going to increment our number of retries. And instead of retry false, we can do something one of my colleagues doesn't like. We can actually return early. So secret.value, return the value. If we drop out of this loop, we reach our maximum retries, or we have another error, another exception, then we're going to return this empty string at the bottom here. Okay, so that should, let's just neaten that up a bit. That should be okay. We can lose now those two lines. Okay, so if we look down here, we can simplify this statement somewhat. So let's do that. I'm going to fat arrow that. So if the retry count is not 0, no, it's greater than 0, then we're going to want to return that value. else we're going to return 0. So we don't need any of this anymore. And this method get we don't need at all. Doesn't do anything for us. We're not calling it. Okay, so that looks a lot neater now. So now we need to just in here we need to just replace that by our new method get skill app ID. Now we've kind of tidied up our configure, and then we pushed our logic for actually accessing the key vault now into this this private method. So let's give that a try to make sure that's working okay. So I'm going to move this off screen so that I can safely observe if it picks up the secret. But what I'm going to do is put a breakpoint here, and then I'm just going to make sure that configuration skill ID is actually, no, I'm going to put the breakpoint, let's just make that a bit bigger. I'm going to put the breakpoint in here, there, and just make sure everything is working nicely. So I'm going to drop this off the screen and run it, just to make sure it's okay. Now on the screen that you're seeing at the moment, you can see that we've actually got, if it was on the screen, we've got some information here about certification, which we're going to follow a bit later on. Okay, so it's running up. Localhost it's still starting. We haven't hit the breakpoint yet. Still waiting to hit the breakpoint. Okay, we've hit the breakpoint, and if I just step over the next line, then again, I think we're working okay. Looks okay. So what we're going to do is bring that back. Let's stop that, and we'll publish that and test it. So I want to test it at every kind of stage, really, so we don't make any errors. So let's push that. Let's just save everything, and then just publish that up to Azure. So how is everyone today? I know this is the early stream, so I've just kind of finished work a bit early. I was working from home today. Is the people still at work, listening at work, or are they working from home? What are we all doing? Okay, we're publishing now. And then I've got the Alexa device here again. I better not say that A word, actually. That caused all kinds of problems last time. We're publishing, we published, just make sure that we're all happy. So values, API, values, yeah, that's fine. And we'll try with our echo. Alexa, ask live coding, who is streaming right now?
Codebase Alpha is streaming now.
Okay, so we're all happy it's working. Let's have a look at the chat. Cody Bid, you finished work at 11:45 last night and started at 7 this morning, and you're still going. Oh, I've had those days. We did a release of our website and our major web app. It was in September the 12th. I'll never forget it. The next 72 hours I worked non-stop for 72 hours because the performance was so abysmal, and I was making all kinds of changes to our service layer to speed it up. I got something like a 500% speed increase, and then I found that the error was in the website, and the third party that wrote the website had made a caching error, and they weren't caching any information and were continually pummeling the service layer, which was at 100% CPU, the machine that was on. As soon as they fixed that, it dropped to 2%. And I'd spent 72 hours manically writing new code for performance improvements which weren't necessary. So this is one of these kind of premature premature optimization stories, really. But yeah. Okay, Gareth, you'll be right back, sure. You so decided that the main corporate site was going live today and didn't tell you beforehand. That's wonderful. Okay. So we've got our refactored code now in the startup method, and we've proved it's working fine. And what we can do is, if we can have a look at the streaming logs here, then there's no errors in here. So we didn't hit our error logging condition. So we're quite happy. Okay. So the second thing I want to do is to do some more work on this request validation. Primarily, I want to add some tests before we go too much further. Yeah, marketing outsourced it. Yeah, didn't involve IT, then suddenly announced to you it's going live. Wonderful coded bid. I do sympathise greatly. So I say we want to move this middleware out of our web app and into our library, so that users of our library don't have to worry about writing custom middleware. We just give them some instructions for how to include it in their pipeline. And if we want to remember how it's being included, it's one of these branching middleware. So we're using the use when method here, the use when extension, which says only use this piece of middleware when the request path starts with /API/the A word. Okay, so that's all we need to tell people to use, and as long as we brought our library and they haven't got to worry about all the logic that's in there, so we can encapsulate all the logic for the certification requirements around the certificate and the signature on the request that comes in from Amazon. Okay, so let's grab this folder and pull it down into our library, and then we can delete it from here. Okay, so now we've got our let's close that. We've got our request, our middleware now living over inside here, and we've got all kinds of errors which we should expect. So we haven't in here. The only packages we've got from NuGet is newtonsoft.json. So we need to bring the relevant packages in, and there's a clue for the first package we need here. It says we may need to bring our HTTP abstractions package in. So we'll do that as the first thing. So let's manage NuGet packages, and we'll browse for that extensions abstractions package, and there it is, and we'll install that. This is going to give us our iApplication builder and associated constructs. So that's that one. And the other thing we want to bring in is the logging, because we've got logging in here now. So let's just flip back to our middleware. You can see now the only thing is this logging that it doesn't know about. So we want the logging abstractions as well to satisfy those requirements. So let's do that as well. Manage to get packages, and this time it's logging dot abstractions. Maybe it's logging dot extensions to abstractions. Microsoft.logging. Nice one. Extensions.logging. Let's go through the whole gamut of possibilities. There we go. That's the one we want. The logging abstractions. So let's install that. Okay. So it looks happy now. And there we are. So we've got, so we can get rid of this comment now, which was a useful comment that was already included when we actually created the middleware class. That comment was already there. And there's our extension method which we need. So So now we can pop across back to our startup class, and this will be complaining now about that middleware. So we need to bring in where's the middleware there, so it needs to be lib middleware, and I need to change the namespace to make sure we're keeping with the correct structure of our library. Okay, let's go back over here. Yeah, I think everything's happy. Let's do a quick tidying up of these usings while we're here. I'll do a build. Okay, so that's good. What we'll do is make sure that we do hit our middleware. So what I can do is we can try popping a breakpoint in. We'll pop the breakpoint in. Let's get rid of that. In our request validation, just pop it there. And if we run up our application, so we're going to go to the values controller first, and that's the kind of default route when we run it as localhost. And as soon as it's up, we'll direct ourselves to the Alexa API. Alexa's just lit up. Sorry, Alexa. And there we are. So we can go over here and Alexa dev streams in, and we should hit our breakpoint, which is inside our middleware, which is now inside our library. So that's a nice, neat thing we've done there. So I'm quite happy that we've now tidied up our code structure. We've brought things which should be in the library into the library. So all concerns here are in our library to do with Alexa. And there's Alexa just complaining about me saying that word.
I'm having trouble understanding right now.
Yeah.
Please try a little later.
Yeah, sorry. Then we've only got just introduced the middleware in our startup class in our web app, so that's pretty useful. So what I thought we could do next, before we do too much more work on the middleware, is to actually write some tests. We won't write a great deal of tests today, and some of the tests that we write, well, we're not going to be able to test everything that's in the library in that validation request, that Alexa request validation piece, but we'll go as far as we can. So let's add a test project to our solution. So we're going to go to the test. It's going to be a .NET Core. We'll use XUnit. I've not really used XUnit much, so this should be interesting. And we'll call it snb dot that word dot lib dot tests. Okay, bring that in. Okay, and we're going to write some tests against our Alexa request validation middleware. So let's rename this Alexa request validation should. Get that changed. Okay, so now we're going to need to do some mocking of the environment. So we're going to need to mock the HTTP requests, the HTTP context, and indeed the iLogger that we've kind of injecting into the validation middleware. So we need to choose a mocking framework, and the one that everyone uses kind of mock or other things like that, but I use Fake It Easy. So I thought, I don't know if you've seen Fake It Easy, anyone, but I like it. So I thought we'd demonstrate Fake It Easy on stream. So let's go and get that NuGet package. So we want to browse for Fake It Easy. And there it is. We'll install that. Okay, that's coming in. Does anyone use Fake It Easy, or what mocking frameworks do people use? I know Mock is very popular. Microsoft Fakes, I think, is another one. Anyone got any preferences? Okay, so that's in there. So we're also going to be using some of the features of ASP.NET Core. So we better have that in our library, in our test, sorry. ASP.NET Core. Microsoft. I'm always quite disappointed by the search features there, so we'll have that. Install that. So that'll give us access to some of the features we need. Mock, yes. I did use Mock in a previous life. When I worked at the previous company, we used Mock all the time, but I don't know why. I started looking for other frameworks, and Fake It Easy was one I liked. And luckily, there's actually because I work with Microsoft CRM a lot. There's actually a Fake XRM Easy, which is based off Fake It Easy, so that's quite useful. We also need the logging, so Microsoft. Let's bring the full logging thing in rather than just the abstractions, and see if that should be okay, because this hasn't got any dependencies. It's not going out anywhere. Okay, so we've got that in there, so that should be all we need, I think. Okay, so I'm going to follow Dev Chatter's convention. We don't really know what we're going to do initially. I think what we should do is test that first if statement there to make sure that's okay. So we're going to pass in these two headers and make sure that we don't get a 400 code returned, and then we'll miss one of them out and make sure we do get a 400 code returned, because that's basically what this is doing. We're coming, are these headers present in the request? If they aren't, either one of them isn't, then we're gonna bomb out with a bad request. So let's do that. So okay, so we're going to need to create some fakes first. So we're going to fake request. Let's spell things properly, shall we? Fake request. So how we define that in Fake It Easy, we just create a new fake, and it's going to be of type HTTP request. Okay. No, not Fake It Easy, just a fake. Let's bring in what we need as far as usings. So bring Fake It Easy in, and then we also need to bring in our HTTP namespace there from the ASP.NET Core package. Okay, so we've got one of those. So that's the request that we get. We're injecting a logger, and we're injecting a context, an HTTP context. So let's create those as well. We have a fake logger. That's going to be a new fake. That's an iLogger, and an iLogger of Alexa request validation. So we're going to need to make a reference back to our library now. So let's go to the dependencies, add a reference to our library. Okay, and then we should be able to bring these in. Okay, so we've got our fake logger, and the other thing was fake context. So we've got fail, not fake. Yeah, the L and the K are together. So var fake context. That's a new fake HTTP context. So those are basically our fake objects that we're going to be using. Now we have to kind of set up or configure our fake objects so that when we access properties on those objects or methods on those objects, we get our kind of the return types we want to test with. So the way you do that in Fake It Easy, you say a call to, and then there's a lambda, anonymous lambda expression that comes in, and this is fake request, and on there is the faked object, and on there all the properties of that faked object. And so we can start off with, we're going to be testing the scheme a bit later on, so let's include a few things just so that we can demonstrate this. And then on the end we say returns, and we're going to return HTTPS. So we're accessing this property on the fake request, and we're saying that whenever you try to access that, you're going to return HTTPS. I think what we need to do is to get our test working is to add in the headers. So those two headers, signature and signature cert chain URL. So let's create one of these. So this is going to be a header dictionary, and we'll use the object initializers. So one's called signature, and we'll just put some fake text in for now. And oops, not those. Need to bring that in bulk of it. No, sorry. That was it called again? I can't remember what it's called. Signature cert chain URL. And we'll just put URL in there. So you've got it. It's complaining to me here about this. Not quite sure why it's complaining. Not valid in the current context. Why isn't it valid? Oh, sorry, that's why. Nobody spotted that. Maybe struggle through that. Thank you if you did notice it. Okay. It's amazing. You type away here, and it's code you write probably every day, and it's so difficult. It's so difficult to actually to do when you're actually streaming. So let's add a call to. Once again, we have this anonymous lambda. So our fake request, fake object, faked object, headers, and that's going to return our headers. Okay, so that's probably enough to actually do the test. In later tests we'll want to build the fake object up, and what we'll do is we'll have the fake object created elsewhere and brought in, so that we can set up a realistic request. So now we need to set up our context. So a call to so fake context dot fake object dot request. That's going to return our fake request. Let's return the faked object. Okay. So now we need to have an instance of our validator, which we're going to test. This is a system under test. Should we call it system under test? Okay, we'll call it system under test, and that's going to be a new Alexa request validation. And in here,
spell ADDITION.
Alexa, thank you very much.
You're welcome.
Okay, so in here we're going to need to pass in. Okay, so we need to pass in what is basically the next parameter. So if you go back over here, you can see it's this request delegate, and I think we can pass that in. Yeah, we can pass that in. What should we call it in HTTP context? That can be a task. From results. It doesn't really need to be anything in particular. That looks alright. And then our logger is going to be, and we need to bring in something here of it. Yeah. The task library. Our logger is going to be our fake logger. Fake logger dot faked object or fake object dot fake logger dot faked object. Okay, so that's set up our system under test, and we want to now we need to call the invoke on that. So this is what we're testing, this invocation here, which passes in the context. So we're going to, because it's asynchronous, we're going to await it, and then we're going to system under test dot invoke. And we're going to pass into that our fake context dot faked object, and we want to make this async. Okay. So now we've invoked the method that we want to test, and we now need an assertion. So here we've got our arrange. Here's our action. Well, in fact, this is our action here. The system under test thing there is part of the arrangement. And now we're going to do our assert. And we're going to assert. I could use fluent validation, fluent assertions here, but we haven't got that package in. I'm not going to bother with that now. We're going to assert that it's false, that the mock context, the fake context dot faked object dot response dot status code is equal to 400, which is bad request. And that's what we return if we go back to our validator here. That's what we return. If it pops into here, then we're going to throw back a response with a status code of 400. Okay. And what we'll also, we can name this now. So not return bad request if headers present. Okay, let's just copy the whole thing. I've got another test which will be so if headers not present, and we'll just change that to is true. Okay. So we should test it. Okay. Run all tests. What's going to happen? So we had a success on the not return a bad request. Oh, because we'd actually, the reason why that failed is we didn't miss out one of these. So let's not include the signature cert chain URL. Let's tidy that up. Okay, so now if we rerun our tests, we should find that that will pass because yeah. So okay, so we've got some tests in place now. So that's a bit neater. We've got some way of writing tests. We've got a pattern now to write our test to. All we're going to have to do is build up our fake request object with the correct values, and it'll get harder and harder to do that because we'll need to find out what values are. But at least what we'll be able to do is when we go and look at the requirements for certification, we should be able to build some tests into that. Not all of the things we can test, I don't think, but we'll have some at least. So let's shut that off. Okay, so let's go over now to the Alexa Skills Kit and have a look at this, what it says here about hosting a custom skill as a web service. So it gives us a number of requirements. I'm just thinking there was one more thing I did plan to get sorted before we move to this. Oh yes. This was that. If you were with us last stream, we created this session-ended request, and I did create a reason object here, and had a bit of a blank on the Newtonsoft stuff we need to do here. So what I want to do is go and look at the reasons, and if we go back over here, I'll open another window. Alexa request JSON. Let's go and find out. There's the documentation for that. So let's session ended request is here, and you can see here that the reason is actually three possible values. So that really sounds like an enum to me. So let's create an enum to cover that off. Then we can at least know we've got session ended request sorted. So we did create a reason here. Okay, so we're going to have an enum. So it's not going to be a class, it's going to be an enum. It's public enum. And we're going to have, so let's go and find out what those, remember what those values were. There's user initiated, error, and exceeded max reprompts. Okay, we'll try and remember those. User initiated, error, and I can't remember the other one. The other one was exceeded max reprompts. Prompts. It's not right. Prompts. Okay, so there they are. What we can then do is we should be able to define these as enum types. So we should be able to put some text values on them. So there is an attribute called enum member. And we're going to need to go and get that out of the serialization, runtime serialization, that's where that lives. And in there we can say that its value is, and we'll just go and grab that out of the documentation. Okay, and we'll just copy that and just paste that down here. That's going to be error, and this is going to be, I'll just get it out off the website again, just so we've got no spelling errors. So we've got that. Let's get rid of those usings. Okay, and then the bit that kind of foxed me last time, which I forgot about, was then we know JSON converter. And the type of is string enum converter, and we'll need to just bring a using in for that, which is the bit that I forgot last time. And this needs to be type reason, which is our enum. So that's kind of tidied that up, which was a bit of a leftover from last time. And it's a good pattern to remember because we may need to use it going forward. So there's other parts of the requests and the responses which we haven't tackled yet. In particular, we haven't tackled directives for dialogue. Last meeting they all done. So you're back, Gareth. Welcome back. While you've been away, I don't know where you left and where you came back, but what we've done is we've moved the middleware out of our web project and into our library, so it's part of our kind of core library now. And we actually added a test project and wrote a couple of tests using Fake It Easy. So we're just testing at the moment that that the presence of the two headers is checked, and the absence of it throws a 400 error, 400 response back. And actually, we've just tested those, and those are running fine. So we've now got a test framework which we can use to exercise most, if not all, of our validator. Okay, so having done that part, I guess we should publish and just do a test just to make sure that we've got nothing that's gone awry. So let's publish. And then we can move on to try and build a little bit more up. Oh, your site's fully live. 1,000 users on. Doesn't exploded, but I've got all my fingers crossed here for your coded beard. It doesn't explode. Yeah. Okay, so we've published. We're publishing still. Okay, there we are, published now. And here's our site. We'll do our test once again. That's API values. It's a bit repetitive under these tests, so I'm just making sure everything's okay. And now we can go here to my Echo, and I can say, Alexa, ask live coding. Who's streaming right now? Alexa, ask live coding. Who's streaming right now?
Codebase Alpha is streaming now.
Okay, so it always seems to be the second time that we have to try twice. It's probably after the publish. I think I've noticed that that seems to be the case, but also using new phrases seems to be that we need to say them twice, and then it starts to pick them up. Okay, so I think what we should do now is have a look at the requirements over here. Okay, so we've got to run under SSL, which we are. We're using a cloud host provider, and we're using one of their certificates, and the domain being the Amazon websites or web services, whatever it is, domain, and that is trusted by Amazon, so we should be fine there. We're not using self-signed. We started this verifying the request was sent by the A machine, and that, if you don't remember, that is over here. So in our startup, we've got this new method which we refactored today. This get skill app ID. We're reaching into Azure Key Vault, which is where I've stored the application ID for our skill. We're grabbing it out of there, and then we inject the configuration into the Alexa controller here, and then the very first thing we do is to make sure that the request contains the application ID, and that is the same as the skill ID that we've got out of Azure. Okay, so we've got that bit in. So we've started to check the signature of the request. Okay. So we made sure that our signature cert chain URL is there, and the next thing we need to do is make sure that its format matches the format used by Amazon. Okay, so let's close a few of these things down. We don't need those open. We can close our test down for now. Reason. So we need to concentrate in here. No, this is Alexa control. We need to concentrate in this one here. So if we pop down to the bottom here, we can see that we're making sure that the cert chain URL isn't null or white space, and if it is, then we're immediately returning a bad request. So I'd like to know what actually is in there. So what I'm going to do is we're going to add a logger command here, and we're going to log information. We're going to output the actual signature chain URL. So URL equals, we're going to do some string interpolation. And it was this one here. Once again, I'll put some brackets around it, just so that if it's empty, it'll become, blatantly obvious that it's actually an empty string. Okay. So let's publish that up to Azure. And then what we can do is to set our trace logging to be at the level of information level. So because currently I think it's error level, so I'll do that while we're here. So what I'm going to do is just move this off screen just in case it does reveal any information which I would rather not share with you. It doesn't look like it is, but I'm going to change the logging level to information. Apologies for being very cautious, but I think it's worthwhile because I had to do some video editing in the last stream because I did reveal some secrets. Okay, so here we have our logging. I think our skill should have, our website should have published. Oh, we've got an error. Okay, let's where are we? Oh, there. Silly me. Okay, now we can publish. So who have we got in chat now? We got Cody Beard and Gareth. I knew this would be a difficult slot for a lot of people to actually come to. So 4 o'clock may kind of morph, but it's quite a good time for me at the moment. But we'll see. Obviously, having just a handful of viewers is fine. It's not, we're not chasing viewers, but it'd be nice to reach more people and to find a time which people find more convenient. But yeah, I think in the US at the moment they're in daylight saving, aren't they? So I'm not quite sure what time it is over there. Probably it's quite early, I'd have thought. Okay, so we're now published to Azure. So let's have a look at this. Let's see if we can find out what that value is. Bring the echo over. Alexa, ask live coding, who is streaming now?
Codebase Alpha is streaming now.
Okay, so what did we get? Did we get any of interest? Don't see it. Let's try again. Alexa, ask live coding. When is Gareth Hubble streaming next? I think because I stuttered there, it's not going to do anything. Thinking though. Alexa, ask live coding. When is Gareth Hubble streaming next?
You have asked about Gareth Hubble and their schedule.
Okay. Yeah, you got to nip out, Cody Beard. No problem. Maybe if we're still streaming when you get back, do feel free to join us. Otherwise, obviously no obligation to do so. Okay, so we can now see we do have some information here. We've got our URL, which is here. So I'm going to grab that URL as an example. And we're going to pop that over in our code here. And we can use that as a test URL later on. So we don't need this anymore. Get rid of that. So that's what it looks like when we get the signature cert chain URL back from the request. So there's some. We're going to have to now look at this, make sure it's the correct format. That's what their website told us. So let's see what they actually meant by that. So we need to check it's the correct format. Let's go over to this link here. Maybe it'll help us. Oh, here we are. So it's got to have HTTPS, case insensitive. The host name's got to be this S3 AmazonAWS.com. The path has got to start with echo.api. If a port's designed, it's got to be port 433. So if you've given some examples of valid and invalid ones, that's really good because we can use these in our tests. which we'll do later on. Okay, so the port's got to be HTTPS, and then the host name's got to be that. Let's cover that off first. Right. So I think what we should do here. So let's make it into a URI. So the certificate URI is equal to new URI, and then we're going to pass in the string, the cert chain URL. Okay. Using system. All right. Okay, so now we can do some tests on that. So I guess it's the scheme first, and that includes the port. So we're going to be a bit kind of cautious about what we do here. So if cert URI so that's HTTPS if there's a port defined. If there's no port defined, it will be the default port, which is HTTP for HTTPS. So so it's not those. So we want the scheme. The scheme's got to be HTTPS, hasn't it? So the scheme equals. So we should be able to get something off this, some statics here. So I've got to be careful with the logic on this. So if it's not that, and it's not that, it's not that or that, not that. And it says it was case insensitive, but let's do a string comparer on there. String comparison. Ordinal case, yeah. Okay. So let's take it step by step. We don't want to get too complicated. So let's stop at that point. So we're testing that we're using HTTPS here, aren't we? Really, and the port is correct. So let's process that. So we're going to do something very similar to this, basically. So we're going to return a bad request. Must use HTTPS. The same. Must use HTTPS. Okay. So that's the next step. So we're checking this portion here, or if there's a port number, which will be sitting here. So let's try that out and make sure we're onto a winner with this. Actually, our tests might tell us, mightn't they? Let's run our test and see what happens. Run the tests. Okay, so this one failed. So we set the scheme to HTTPS. So port, we haven't defined port, so we need to do those things. So let's set that up in here as well. Port. Oh no, this is not right there. So this is we're talking about something completely different now, aren't we? So we can't just run our tests. We're looking at the URL, and we're not passing a URL in. Let's pass a valid URL in. So let's go back to our code over here. Let's grab this here, pass that in, and try running that again. Run the selected test. Okay, so it's happy now. So that's fine. I guess we need to pass one in that's not happy now, don't we? There, so to make sure it fails. So let's just copy our. So we'll tidy all these tests up at some point. At the moment, I'm just going to have a whole load of tests. We can refactor this quite heavily. So let's change this to HTTP. So we're going to return a bad request if not HTTPS. If cert URL not HTTPS. We'll run that. And it's going to fail because we were actually asserting that it was true, it was false there, and we need to assert that it's going to return a bad request. So I think it was worth spending a little while creating those tests. So that looks happy. Okay, so I think that's pretty satisfactory. Let's close that down. So the next thing we wanted to do was make sure that the host was equal to something. It was this s3.amazonaws.com. So let's check that. So if cert URI dot host equals so let's grab this piece of text here. We're going to set up a constant private const string probably the host name, make it that, valid host name, and if it's not equal to that, and we want to do the same, we want to ignore the other string comparison bit, or ignore case. So then if that's the case, then we want to do something very similar here. Certificate URL has invalid host name. And we'll just copy that down to our what gets returned. So we can see it on the screen if we do this manually. Okay, so that's that. So let's go back to here. Once again, as I say, we'll just duplicate tests because it's going to be nice and quick for the stream. But we'll probably need to go and, if not certificate, if invalid cert host name. Dev. Okay, that should return a bad request in that case. So let's run those tests again, make sure we're actually on song here. So it's a really quiet stream today, so I do apologise for not being many people around. It's this obviously not going. It might possibly be a good slot. Just need to publicise it more, perhaps. But yeah, there we are. We've passed all our tests, so we're happy there. Okay, so what's the next thing we need to do with our validator? We've checked that the hostname's correct. Let's go back to our website, and the path needs to start with echo.api, case sensitive. Okay, so it's going to be very similar to this, isn't it? So let's again. Set URI. It's an absolute URL. That's an absolute path. That's what we want. Absolute path. Starts with what we used before, and it's got to be echo.api. So if it's not that, then we can just do another. So certificate URL has invalid path. Once again, we should go and create a test for this. If invalid certificate path. So we connect this to com, and this was echo. We'll change that to the A word. And what I'll do at some point is to bring in all those test URLs in, and we'll test each of them. But actually, I'm not quite sure how to do. Actually, we can do that with a theory, can't we, in XUnit? No, I've not used theories in XUnit, so I'll need to read about that. Then we can pass a sequence of URLs in, some which are good, some which are bad. Yeah, so that'll be a good learning experience for me. Okay, so that should fail. Yeah. So let's run the tests. Did I say run all? Run all. There we go. Yeah, we've passed. Okay, so we're kind of bombing through this at the moment. That's quite impressive. Okay, so what's next on the list? We've checked that the certificate URL, certificate chain URL, is of the correct format as used by Amazon. So what's next? We'll look at this. We'll check the timestamp of the request. What's it say here? Your service should allow tolerance of no more than 150 seconds, 2.5 minutes. This means that the device should expect requests Its timestamp is within 150 seconds of the current time. So this is for kind of replay attack defenses. Okay. Should we do that bit next? That sounds like a reasonable thing to do next. Yeah, we'll do that bit next. So, okay, yeah, why not? So that'll sort that bit out. But there's more to do with the certificate, because there was a longer list than that, wasn't there, down here? There was things about downloading the X509 certificate, so we need to do that. Well, let's sort out the so we can do the we check the application ID here. If we go over to our request, then in the, I think it's in here. No, it's not in there. In the request. So request body. Then we get timestamp. So we should be able to use that to check that we're within 150 seconds of the current time. Okay. So naming a variable. I'll call it time for now, but that's a terrible name. So we want date time dot UTC now. So that's the time now, and we want to subtract away from that. So let's extract out the timestamp. That is on the Alexa request dot request body dot timestamp. So that's that. And that's going to be a date time, and we want to subtract timestamp. So we call this time difference. Time difference timestamp. Total seconds. So that should be a double. Okay, that sounds reasonable. And then if time difference is less than or equal to 0, or time difference is greater than 150, then we want to do this. Return a bad request. So timestamp not within tolerance, not within accepted tolerance. Okay, I think we better test that hasn't broken anything. So let's build that. We'll publish that. We don't need request body. Let's publish our web API and just do a quick check. Make sure we're not causing any issues. Okay, so we should be able to go here and see anything that happens awry will be logged here. Come on. Publish away, please. Yeah, there we published. So we'll sit on our, we'll get rid of that. We'll sit on our streaming logs, and we'll. It seems that we have to kind of ask it a couple of times before we see the logs fill out properly. So let's try it. Alexa, ask live coding, who's streaming now? So you can see that it's behaving the same way each time. It's quite consistent. We don't get a response the first time. But just think about it for quite a long time because it's listening to my voice now. Alexa, and now it's going to bomb out.
Sorry, I'm having trouble understanding right now. Please try a little later.
Alexa, ask live coding, who is streaming now?
Codebase Alpha is streaming now.
Okay, so we're quite happy then. It's passed that test. It's not logged anything. Actually, it's interesting. It's got this validation state because it's valid here. I wonder what that is. That's interesting. Anyway, let's go. So we've got that working. Let's go back to our checking the signature. So yeah, so we've got our time. So we're kind of defending ourselves against replay attacks now. So we need to go back to here to our validation. Okay. Right. Think about this. So we've checked that. So now we want to download the certificate. So there's an X509 certificate. Okay. So there's probably a number of ways to do this. There's new ways of doing it, isn't there, with HTTP client factories. I'm not sure. I've not looked at those, so I'm going to do it. I'll do it the way I know, and then we can look at how to do this with a HTTP client factory and sorting it out properly. So we're going to do it using so we're going to create a client. I don't believe you need to do this with a client HTTP client factory. We'll get rid of client. And we need to bring in system.net. Okay. So you're going to get a certificate, and that's going to be client dot. Actually, we could do this doing async, couldn't we? So let's get a HTTP client, and then we can do. We are in an async method after all, so we should be able to. No, I think I'm going to stick with the way I know it, and then we'll go and change it later. Oh, there is an async. Look anyway. Download data async. Okay, and that's the cert URL, URI. Can we get the certificate from there? Cannot await void. Okay, we'll do it this way, and then I'll have to do some research on this. I think async await. I know some things about it, and then other things just floor me, like that one. Okay. Oh, I suppose we needed to. Did we need to? No, we'll carry on like this, and I'll do some research, and then we can come back to it. It's one of those things that I don't really particularly want to have to think about too much on the stream, but I can do a bit of research and come back and be a bit more positive about what we need to do there. So certificate data, certificate is that's going to be a new X509 certificate. So data. So we're going to need to bring something in for that. Yeah, so we need system cryptography. Yeah, get that in. Okay, so then we've got our certificate. So what does he want us to do? This is where it gets more difficult in terms of writing tests. So we'll see. We're not going to be able to actually have a certificate necessarily at these locations, but we should be able to at least call in to a valid certificate chain URL and get something downloaded from there. So that'll be interesting to see what we can do in terms of writing tests for that part of it. We should be able to do something. So let's have a look here. So we download it. The chain periodically. So okay. Resilient to different URLs, different content. Certificate should be composed of in order the Amazon sign-in certificate and one or more additional certificates that create a chain of trust. To confirm the validity of the sign-in certificate, perform the following checks. Sign-in certificate has not expired, so we need to examine the not before and the not after dates. Hi Draco, Jacob. Yeah, you're the space nut, aren't you? Along with me. So some very interesting stuff you posted about the NASA budget. Have you seen the latest Scott Manley video podcast on the NASA budget and what it means for the SLS? Yeah, it sounds like SLS, unless Congress change things, which they may well do, because there's a lot of advocates of the Space Launch System, that's SLS, the new rocket from NASA, the new rocket and Orion capsule. It sounds, unless Congress change the budgets, and I know there are some fans of the SLS in Congress, it sounds like it could die. It's going to be funded, I think, according to the budget request, funded only for the initial phase, which means it won't be powerful enough to launch the components of the Gateway lunar station, and those will have to go to commercial providers such as the Falcon Heavy. So there's some interesting things in the next few days. If you're interested in space, but you're not interested in American politics, wait until it all comes out at the end and we find out exactly what the budgets are. And people like Scott Manley or there's another great guy on YouTube called The Everyday Astronaut. They will do some videos and analyse what it actually means for NASA's space program, because they've been very bullish recently about the Moon to Mars kind of project, and the moon base and Gateway station and commercial lunar landers and all this. But the SLS is pretty important to that. Unless we do go way, kind of, I'd like to go and give all that money to SpaceX and say go and build the BFR. Yeah, EM1. Yes, EM1 on a private rocket. Yes. Anyway, let's get back to this. So we've got to check the not before and not after dates on the certificate. So we've got our certificate now. So let's get an effective date, date time minimum in the value. Just set some default values up. Expiry date. actually, what I must remember to do is bring in IntelliCode. That would help a bit with some of these methods that we're choosing. I don't know if you've come across IntelliCode. It's basically scans your code base and looks at what methods you use on various objects the most, and actually bring those to the top. Quite smart. Okay, so we've got the expiry date and the effective date. Let's go and find out what's actually on the certificate. So var cert expiry date is going to be the certificate. Get expiration date string. Okay, so we can do a try pass on that. And this has got to be and expiry date. Yeah, tidy that up a bit. It was a really messy bit of typing. Certificate dot get expiry dates. That's going to be a method, isn't it? Okay, there we go. Is that same bit? Yeah, there we go. And we want the what did it say we needed? We needed the effective date as well, didn't we? So it was the not before and not after. So the effective date is the not before, and the not after is the expiry date, basically. So let's get that as well. We can copy this line. Effective. Effective. And get effective date string. Okay, so if we don't need these. So if not effective date or cert effective date is less than date time UTC now. So that's one failure condition. And the other one would be not found, didn't find an expiry date, or the certificate expiry date. Such an expiry date. Let's make sure we get this the right way around. Expiry date is greater than date time now. Is that right? It's the effective date. So the expiry date is, no, that's not right, is it? The certificate date has got to be before now. Is that right? Help me out, someone, with the logic. This doing date logic on screen is doing a head in. Effective date is less than date time now. So it's got to be effective before now, and it's got to expire okay. It's got to be the way around, doesn't it? If it expires before today, and the effective date is greater than, if the effective date is greater than now, then it's not effective yet. It's a future effective certificate, and the expiry has got to be greater. So if it's not found, or the expiry date is it's already expired, then we got to bomb out. So let's put some of this stuff in here. So we're going to say certificate is not yet effective. Pop that in there. So Jacob, you still there? Where are you from, Jacob? You're in the UK, in Europe, or the US? So it's expired. Okay, so what we can do, we should be able to run our tests, even though we haven't got an explicit test of this. Presumably, we should be able to download the certificate, yeah, and it should meet those requirements. So it'd be interesting just to run the test to see what happens. So let's run all tests. I didn't see them run. Let's run them again. Yeah, so it looks like we're okay. We actually probably did download the certificate and actually test it, which is good, because we get into the kind of area where I'm just really not sure how we're actually going to so pass it a bad certificate, which kind of has an expiry date or an effective date, which is not what we want. Okay, let's go back to our website and see what else is next. So we've done the dates. So the domain has got to be echoapi.amazon.com in the subject alternative names section of the sign-in certificate. Okay. Well, we've got a certificate, so we should be able to look at that. Let's have a look. Okay, so we've got certificate dot what are we looking for here? The subject, isn't it? So does that contain? So we have to think back now to our kind of the way certificates reference information, and it's like this. So CN, and that's got to be that that name there, that domain. So we've got that there. So it doesn't contain that. Then once again, so I'm keeping all these if statements kind of separate so that we can kind of just step through each logical test is separate. We could kind of combine them all into one massive, really confusing if statement, I guess. But as I found when I got to this effective date and expiry date, it starts to get a bit bamboozling when you don't think about it kind of carefully. And if it was too much, it was too complicated. I think we just get so confused we wouldn't know what's going on. So so it'd be an invalid issue, wouldn't it, if the domain wasn't correct? Okay. So there's something about it's got to have the certificate authority's got to be right. So we've got the subject alternate name. All certificates in the chain combine to create a chain of trust to a trusted root CA certificate. I'm not sure how to do that bit. So a trusted certificate. So we need this certificate authority. But what is the certificate authority we should be testing? It's just a trusted one. Is it going to help us? So if it doesn't pass those, okay, we've tested all those. Checking the timestamp of the request. Okay, so we're going to have a to-do in our code, I think, to figure out how to do that bit, because I'm not sure, to be perfectly frank with you. So let's put a to-do in. And we'll have to come back to that part, I think. Yeah. I wish I could think of a way of doing it. Okay, well, I can't think of a way of doing it, so. Okay, let's see what we're going to do next. Once you determine the string something is accurate, extract the public key from it. Okay. Okay. Extract the public key. Okay, I think I can do that. Okay. So so why does it want us to? We want to hash things together, doesn't it? Base 64 decode the signature header. Okay, so we need to get that. We need to get the signature. Okay. So let's do that part. Let's grab the signature header value on the request. So we tested that we had a signature before, right at the top, and this is where it comes in, because I was wondering why that was there, but we need to grab that. So we need to get the string out of that. So okay, so we had some code up here which we can steal. So let's have a look at this. See if we can reuse this. Signature. I'm going to run out of names here. Signature, not signature, signature, there we are. Signature string, sig string, I'll call it that. So we've got the first one. Okay, so we've got our signature. And we want to do a base 64 encoding of that. Okay, so we can do that. We're going to run out of variable names. So sig base 64. So if anyone can think of better names for these things, do kind of fine. 2 base 6 from base 64. Base 64 string, and that'll be the sig string. So sig from base 64. It's a terrible name. Come on, guys, help me out with some names. We'll come back and have a look at that. So we've got the signature. Base 64 decode. So we'll call it. Yeah, we'll change. What we'll do, we'll call it decoded. Signature decoded. Yeah, signature decoded. We'll call this signature string. Let's not use abbreviations where we don't need to. Signature string. So signature decoded, that's our base 64 decoded value. And then what we want to do with it. Use the public key extracted from the signing certificate to decrypt the encrypted signature to produce an asserted hash value. Then generate a SHA-1 hash value from the full HTTP body request body to produce the derived hash. Compare the two. Right, okay. So we're going to have to use the SHA-1 hasher. So a hasher is going to be a new SHA-1 SHA-1. Let's say managed. Dredging this out of my memory. My certificates. That's in the cryptography package. Okay. So we're now going to have to read the body of the request, aren't we? So body equals HTTP context dot read request dot read Okay, so we're going to have to write a method to do that, aren't we? Because we can't just read the body out, I don't think. Rumbling Geek, hello, welcome. We're kind of deep in trying to work out how to read. So let's just comment that out for a second. Let's create a new method to actually do this. So let's make an extension method down in here that will read it. So public static. We'll make it async because I'm sure we're going to want to read it asynchronously. Return a task type string because we're going to get a string back. What should we call it? Read HTTP request body. Request. Let's spell it right. How are you, Rambling Geek? Nice to see you. We'll follow the convention of putting an async name on there. If I could spell it correctly. Async. We're going to just pass in. It's a static. It's a extension method. So we want this HTTP request. Okay. So then we want to. We're going to do a stream. We're going to read from this. It's a stream thing. We want to read a stream. Good. I'm glad you're well. I hope to catch your stream on Friday if you're going to stream Rambling Geek. So look forward to seeing you there. So we need to get a stream reader. So a new stream reader. Let's do stream reader, and it's going to be rec dot body, and we need to pass an encoding in. Let's get a stream reader in first. I called it rec, didn't I? There we go, rec. We need the encodings as well. Text. It's going to be UFT8. So get that and turn await reader dot read to end async. So that should get us our body, and then we can simply have. We've now got an extension method on the request here, which is this read HTTP request body async. We need to pass into that nothing. Okay. So that's our body. Got that. Got naming again. Naming. Oh god, there's data. Help me out. Might be Saturday. You may have to work. Yeah, Saturday might be quite hard. But is it in the evening that you broadcast? It might be okay in the evening for me, but during the day would be difficult. I do want to catch your next stream though, Rambling Geek. So the data. So we want to hash this, don't we? We want to hash it. So we've got our hasher. Hashed body. Sounds a bit weird, isn't it? It's hasher. So we should be able to. Well, they got compute hash. That sounds like what we want. And then what does that take? Takes a buffer. So we're going to need to this might get a bit messy. New what is it? Uni can't remember. Unicode, not Unicode. Unicode encoding. That's it. Yeah, encoding. And into that we need to pass. Any of those get bytes. Pass the body into there. I'm missing a bracket. Okay, so that looks. So that is. So we haven't completed it, have we? So we need to await something. We need to await that. Okay. So I don't like the look of all that. So let's extract this part of it. Encoder equals that, and then we can put encoder in here. So my wife's returning. See the car pulling up. So I'm going to have to stop very shortly. We're going for just over 2 hours. Let's see if we can get a little bit further. So we've got our hashed body here. So we said we needed to extract the public key from, so that's what it said in extract the public key from the signing certificate. So we should be able to do that. So let's do that. So there's that bit we've got to do. So for our public key, and that's going to equal cert dot so we should get the public key from this. So how do we get that? This is getting difficult. So we need a kind of that's because we got the wrong thing there. Cert. They call it a certificate. No, get public key. There we go. Get public key. Get public key should be okay. So what does that give us back? That's bytes. We don't want bytes back at that point. So we're going to have to cast that. Now, it's something like RSA crypto service provider. I think that's it. Cast it as one of those. So what I'm going to do, rather than using var at that point, I'm going to put the type in the. I thought it was public key dot key actually. Get public key. Turns a public key as a array byte. Can't convert that. Okay, well, we've got a public key as an array of bytes. Let's see what we can do with that. Can we use the public key to do anything with it though? I don't think we can use it to hash things. It's just a key. Have we got any useful methods on here? So we want a crypto provider. Dot certificate. What have we got on here? We haven't got public key on there, so get public key would seem to be get public key string. There's a hexadecimal string. Let's try getting this as a string and then passing that through that RSA crypto service provider. It still can't convert it. So we're going to hit the internet, aren't we? Let's try this. So C# extract public key as crypto provider. Okay. I have to read the public key from a PEM file. So here's so you can read public keys from XML using the from XML string method. So this RSA crypto service provider is what we want. So what has it got that might be of use to us? Doesn't seem to be much use. Key encryption in that, cryptography, how to generate keys, not really much use to us. How to load the public key from a file. Okay, what's this here? Convert from base64, so get key, was that get key there? Let's have a look what this is doing here. Get key. And what's get key? Get key is reading it from a file. Convert from base64. So we got it as a string. So that's begin public key is a string there, isn't it? Okay, well maybe we can leverage that. I'm using all this load of private methods down here which they've invented. Don't like that. Let's go back and see what we can do here. So certificate is our certificate, isn't it? Our X509 certificate. So I'm confused why we can't get at the public key. Let's just do a certificate dot. So get public key. It's sitting there nicely for us. Yeah, what we're doing, what we're going to do is we're going to make sure that it's the same certificate that was used to encrypt the body of the HTTP request. Rambling Geek. And what I need to do is get the public key. We can grab the public key as a byte array or as a string. So I wonder. So we got it as a string. It's a hexadecimal string. It's a hexadecimal string. So we need to convert. We need to be able to use it then for to do the hashing. Yeah, to verify the source of the request, make sure it's come from Amazon. We're doing all kinds of tests here, so this is all part of the certification requirements for your skill. So if you can't pass these tests, then Amazon won't allow you to publish your skill and have it used publicly. I'm struggling, to be honest, chaps. I'm struggling. We're coming up to an hour and 2.25 hours as well. I'm going to finish very shortly. Let's see if we can do one last thing. Yeah. Sorry for the dead air. Sure, Snowball. First or default. Where? Oh yes, yes. Yeah, we'll sort those kind of things out. Don't worry. I'm just struggling with this public key business at the moment. So I'll comment that out. What's going on below that? Oh, that is okay. Certificate. Certificate is a X509 certificate. So my recollection was that you could get the key. So this is returning a byte array. Convert byte array to RSA crypto. What's it called again? Crypto service provider. Correctly create a crypto service provider from a public key. Okay. Is this going to be of any help? I'm not sure it is, to be honest with you. Okay, that's what I've got here. You see, this is what I remembered. This is what I remembered. Our certificate 2. Okay, let's try that. Yeah, so look, it's got it's X509 certificate 2 there, according to this. And I've just used a 509 certificate. So let's try that. And then what I remembered was public key. Yeah, there it is, public key. Got key. Yeah, so this is our crypto provider. So see if the crypto provider is null, or so if we didn't get the conversion, or or basically the crypto provider. Well, we should have a verify hash. We do. Yeah, this is coming back now. Verify hash, and we want to verify the hash. So what did we call it? So we need to bring this down. Actually, we're in the wrong place for this. We should be inside here. So this is hash body. Oh God, dredging up the memories now. Yeah, it's a SHA-1. We've got to tell it it's SHA-1. So we've got the hash. So cryptoconfig dot I think it's that one. Map name to OID, and that's going to be SHA-1. Yeah, this is, we get into kind of this cryptography stuff, and it's a bit, yeah, it's a bit weird, and I'm having to think very hard. I'm going to compare that to the signature, don't we? So this is signature decoded. Okay, well, oops. Yeah. I think that's okay. So what's that going to return? A boolean. So if it's not, if it's null, or we didn't verify, then we want to return our usual stuff, don't we? Okay. So it's not invalid. It's we'll leave it invalid to be for the moment. So that's all a bit speculative, isn't it? Invalid key, basically. Invalid certificate key. Yeah. Okay, what we're going to do is run our tests and see if it breaks everything, because that'll be, should give us some, if it doesn't break, it should give us some confidence that it's actually working. Let's run all tests. If it does break things, I'm going to have to stop the stream, I think, and have a think. But yeah, so it failed the first one, which is the it shouldn't return a bad request. Yeah, sure. I will go through and change that kind of stuff. Don't worry. So let's just try that again. Yeah. So I'm doing something slightly wrong somewhere, and it's going to be a bit difficult to actually work this out. But let's try. Let's place a breakpoint here, and we'll debug this test. Yeah, I'll get rid of all the hard coding stuff. I've already got a constant up here for the host name, so we'll go and do that kind of stuff. I think this is such a speculative part of Yeah, it does make sense, Rumbling Geek. It's just I'm dredging this up from memory, and I've already fallen foul of a couple of things here. So let's see what we get. So we get a crypto provider. Did that? Okay. Unable to cast object type. Unable to cast. So it failed on that cast, didn't it? So let's just try that again. Unselected test. I thought I had a breakpoint in there. I did. Debug selected test. So this gets an RSA crypto provider or a DSA crypto provider object written. So we probably don't need to cast, do we? Do we need to cast? Let's try not casting. If it's saying it can't, does that turning up? Then verify hashes. So what have we got other than that then? Okay, so we do need to try and cast it. And it says it's invalid. What have I just done? Yeah, so I'm not. So this needs to be that RSA. Let's just revert it back. That does need to be that type. So we did find something here, didn't we? So that's what we're trying to do, and that's basically what. So that's basically what we're doing. We're passing the certificate bytes in, getting the certificate out, and then let's just copy that whole piece of code, in just in case we've got something awry. Which is this one here. Okay, so I'm fairly determined that we sort this out on stream, but if we can't, then you'll understand. Yeah, it is pretty complex because we're having to prove. Yeah, this is why we want to build a library so that ordinary mortals don't have to worry about this kind of thing. So this is all going into our Alexa library, and all people will have to do in future is just to include this middleware in their project, and it will do this, so they won't have to think about these complex aspects of certification. So really, it's the way we kind of provide a service in the NuGet package to our users. Extract away all of the difficult stuff, and they just say, I want to plug in this validate request middleware into their pipeline in the MVC, in the web API, and it'll just do it for them, and their Alexa skills will pass validation as long as they meet all the other requirements. It won't fail on these technical requirements. So let's pop a breakpoint there again, and we'll debug again. So this is definitely the same code as in that. So it bombs out straight away there. So it's not enjoying. It's not enjoying it, is it? That can't do that cast. Why can't it cast it? This is very, very annoying. Okay. So the public key, it gets a public key object. What else have we got on here? Encoded key value. What's that? So we're gonna resort to so that doesn't like it, does it at all? It says you can't do that. But it wasn't fussed about key. It thought it probably could do that. So key is an RSA or DSA crypto service provider. So let's go and have a look about DSA. So it must be a DSA crypto thing that it wants to. It's one of that gets one of those two things. Can we tell it which one to get? Doesn't look like it, does it? There's not an awful lot for us on there. So if we change that to a DSA crypto service provider, then we get a problem down here, do we? Then verify hash. Is that going to be happy? Okay, let's see what happens. It fails as well. Okay, so let's go back to first principles here. And fire that. Let's put a try catch around it. Let's see what the exception is. I think it's going to be it can't do it, but exception. Log error. Extra message. Okay. So what we're going to do is we're going to stick a breakpoint in there, not there, and we're going to debug again and see which catch it. Build error. What have we done? But what did I do? What did I do? Right. Let's move this all the way down. It was right the first time, wasn't I? Yeah. Okay, let's just tidy that up. I don't think we're going to beat this tonight, chaps, I'm afraid. But we'll just give it a little more effort. So where did I put my breakpoint? I want the breakpoint to go there. Okay, let's try again. So good job we've got these tests. They do help us. So it can't cast the object of type RSA-CNG. Yeah, if we go over here, let's just stop. If we go over here, it says get an RSA crypto service provider or DSA crypto service provider object representing the public key, and yet that's not what it is. No one with any crypto experience in this chat at all? Phil Snable, have you got anything with cryptography? Because I think I'm starting to get a bit confused. This is one of those moments where I really would like to solve this on stream. I really would. So the code looks great, doesn't it? It looks fine. It all compiles, but this SSL, yeah. Well, this is the nitty gritty of all that kind of stuff, isn't it? So, Gambling Geek. So, I think this is going to have to be taken off stream for some research. But what I will do is not actually, I won't fix it off stream. I'll actually fix it on the next stream, I think. Where we're going 2.5 hours. Yeah, guys, I'm really sorry. I'm gonna have to fix this off stream, I think. Thank you for all the people who've viewed. It's been fantastic. It's been a quiet stream, but we got quite a lot done. We got the refactoring we wanted doing in the startup class, and made the code that we copied out of the Microsoft document actually work and do the proper retry throttling. We moved our request validation middleware into the library where it belongs and fixed that up. We created a little test suite for it, and we almost got to the end of actually coding that. Store Penna, we're just about to finish, I'm afraid. So thank you for joining, but it's a bit late. So we've run into a bit of a problem. This piece of code here, if you've got any crypto experience, maybe you could throw some light on it. This piece of code here, it compiles, it looks great. The key we're extracting, the public key, says that it's either an RSA crypto service provider or a DSA crypto service provider, but this cast fails. I guess what we could, did we try not casting? I'll just try that once more. So then this is an asymmetric algorithm, you see. Asymmetric algorithm. I'm sure that won't work. It's just another way of phrasing what we were doing anyway. So let's just give it a run, but I'm not confident. Oh, it's null though. It failed to do it. So it would bomb out at this point rather than exceptions. Bomb out with this test here. I'm just fascinated that it says it's of type RSA CNG. Let's persevere for just a few more minutes. Convert RSA CNG to RSA service provider. Yeah, it's addictive, this stuff, isn't it? Coding, isn't it? Or don't you always say, just give me one more minute, just a couple more minutes. Okay. So this looks interesting, doesn't it? Let's convert that way. I'll change to what's this do? So there. So we've already got what he's trying to get. CNG. Let's just have another window. RSA CNG. I'll put .NET in there. So I wonder what methods we got on that. We haven't got verify hash. We're going to export RSA public key. No, it's just getting a byte array again. So anything to do with hashes, sign hash. Try hash data. So there's some stuff inherited, look, from the verify data. Verifies the digital signature is valid by calculating hash. Ooh. It's got span, look. Read only span. Should we give that a go? Oh, I don't know, look. Don't know what all these are. Verify hash. Byte, 2 byte arrays. Verifies the data was already hashed. So, ooh. So, if we just take it as it comes, so let's stop the program. Whatever it is, then verify hash. It wants verify hash is no it's asymmetric algorithm. So as RSA CNG. That's what it said it was, didn't it? Confusion reigns. Doesn't know what that is, so let's have a look. No idea what that is. So this says it's a asymmetric algorithm. Let's look up asymmetric algorithm. .NET symmetric algorithm. The asymmetric algorithm class. Can't stop, yeah. You gotta keep on pushing. So what's it got on it? What method has it got? Nothing much. Export private key. It's getting bytes again, isn't it? Convert asymmetric algorithm to RSA crypto service provider. So there's a reading from XML. Right, guys, I'm going to stop. I'm not getting anywhere. I will check in the code, even though it's got this bug in here. We'll just cast that to RSA crypto service provider, which is what we want. Even though it's got the failing test, I think we better check in what we've got, and I'll do some research off stream. I'm sure we can find out what the problem is, but I won't fix it off stream. I'll fix it so you can all see. So thank you very much for viewing. Sorry that we're kind of stopping when we've got kind of our peak viewers, but been going for nearly 2 3/4 hours now, so It was a bit longer than I anticipated. So once again, thank you very much for viewing, and I shall see you very soon. Bye bye.